So the first thing I want to go through, we kind of looked at how to make the ERD diagrams yesterday. So the first thing I want to go through is how to start to take that and turn that into an actual database. So you did kind of a little bit working on your own with the resources that you could find, but I wanted to make sure that everybody kind of has some idea of how to do that and some of the tools you might want to know about some of the other commands. So I'm going to walk through that here. You don't need to follow along because as soon as we're done with this example, I'll have you go back to your groups and split up and do this. Take the ERD that you made yesterday and turn that into an actual schema. Point being, you don't necessarily need to follow along with this right here. Okay. So the output of this is going to end up being that I have a single script that can completely set up the database with including some data entry toward the end of it. Cool. Questions about that?
So we're doing this one?
So this is what I'm basing it on.
Okay, so we're going to turn that in.
When you build your schema, it will be based on the diagram that your team made. Does that make sense?
So the one we're building is the team one, not this one.
Not this one. So
okay.
I'm going to go through this one as an example to keep it simple, right? So I've simplified it down to just the three tables: the order, the product, and the order product. And I think with just those three tables in place, I think you can figure out the rest. So I've got on the order table, I've got an ID column as the primary key. I've got a payment date and a shipment date. On the products, I have their ID, name, category, and price. So I've only got just a few fields on both sides there. In the middle, we have the order ID and the product ID. Those are going to be your foreign keys that reference the other side because we got a bridge table here. And those are both, I'm going to use those together as the primary key to make a composite key. And then I've got quantity and price. You might ask why I have a price in the middle. And that comes down to oftentimes the price that people pay for the item may not be the same as the price in the store. Because basically this price here, right, is the price in the store or the current price in the store. So that price could change up or down, but we need to record how much the customer actually paid. So for instance, we can do refunds and returns and the like, because they may have bought it on sale or we may have raised the price. We don't want to give them the wrong amount in a refund. So that's why I put the price in the middle as well. Okay, so when I'm turning this into a schema, there's a general kind of rule of the order you put things in does matter, right? So when I'm putting in foreign keys, the table that they're a foreign key for has to already be there. So I can't put in the order product table until I have the order table because I need to reference the order ID. I also need to reference the product ID, so I need to put products in first. So I'm going to do the order and the product first. I can do those in either order, but I need to do those before I do the one in the middle. Does that make sense? So you kind of start from the parents. You can think of it starting from the parents and then working your way down to the children. Okay, so I'm going to go to Workbench. Okay, and what I want to do is start a new query. So
you're going to need to change your screen. We can't.
Okay. Yep.
Thank you.
I forget when I stick it on that. It doesn't. Okay. All right. So we're in Workbench here. So in the top left, I'm going to click on New Query, which is that button here. So now I've got a new query started. I'm actually going to go ahead and save it just so I have it somewhere and that I can hit save in the future. So I'm going to hit save script. And for now, I'm just going to save that on my desktop. Usually I would save that into some sort of project folder, but I'm going to just save it on my desktop. And we'll call it schema.sql. Okay. Yes, I do want to replace that. Okay. So I'm going to save it as schema.sql. The first thing I need to do, obviously, is to create the database. Okay. So to create the database, I want to write in create database, and I think the name I'm going to give this one is Cowboy Boots 3, right? And the only reason I'm using 3 is assuming you may have done 2 versions of this already, so I'm not, if you want to try this, you're not overwriting the other versions that you had created. So that's what I'm calling the database. I also need to specify the default character set. Default character set. And I think on Monday I maybe listed that as UTF-8. I did a little bit of research and noticed that was maybe misinformation because, as it turns out, the UTF-8 in MySQL is not actually UTF-8. There's kind of a bug with it. So they implemented it not per the UTF-8 standard. So it's actually better to use this one, UTF-8 MB4, which is short for multi-byte 4. And basically what it comes down to is the current spec for UTF-8 is that your full characters are actually 32-bit or 4 bytes. And that's the kind of the longest they can be. But the way that MySQL had implemented UTF by default, it only goes up to 3 characters, which means if you just use UTF-8, things like emojis don't work because they need 4 characters. So I want to use UTF-8 MB4 instead of just UTF-8. So that's what I'm doing there. Jonathan, I know you sent me a message, but at the moment I can't read it with all the applications I have. So if you have something, please just say it in chat, as I can't really get to my messages right now. So collate then also needs to be, it's going to start with UTF-8 MB4. And then I want to say general. Okay, so that covers most languages, and then CI. So remember, this is going to set it to be case insensitive, right? When we do our SQL. Okay, so that's the character set you want to start your databases as. Start them as UTF-8 MB4, and then the collation as that. I think on Monday I had said just UTF-8, but that does need to be MB4. Okay, so
collate English. What is that?
It has to do with how you do comparisons, how you define equals. So normally, when I'm comparing 2 things, I'm comparing a string that maybe the user has input and a string that's in the database. You want that, should that comparison be case sensitive or case insensitive? And for most database things, you want that to be insensitive. Does that make sense? Case insensitive. So if I type in foobar, it doesn't matter what case it is between what the user typed in and what's in the database. Does that make sense?
Okay, so it just makes it case insensitive. That's what we're doing.
It just makes it case insensitive. That's what's important there. Because you want that to be the default. Okay. Okay.
I probably just missed over this. Do you want us to type out the database like that, or are we okay doing the shortcut with the...
You'll end up needing to put this in your script. Because I need this script to be able to make your database locally. Does that make sense?
Yeah. So if we do the shortcut through the button, doesn't it give us information that we can then copy and paste?
You can. One thing that you can do, if you say, once you've created it, you can say, send a SQL editor, create statement, and that will kind of generate it here as such. Mm-hmm. But what I need is, I need everything to be, all of this stuff that we're talking about here, I need that to be all in one script. That's kind of why I'm doing it just by hand today.
All right.
Does that make sense? So even if you started it with doing the editor, I need to end up putting it into a script. Does that make sense? Because I need to know all those things, like what is the name of your database and all those pieces. Okay.
When we're putting this together,
yep.
and we're like, let's just say what we got right now, it's not enough, but how do you try it to make sure that it's working without creating extra files? Because we have this, right? I mean, you might have a syntax error in there. I don't know. Mm-hmm. But we're certainly going to have them. So how would you test it?
You just hit execute on it.
Okay.
Right.
That's it.
So there's a button right here to execute it. So I can run that once, but you'll notice if I try to run it again, see what it says down on the bottom? So it says can't create the Cowboy Boots database because the database already exists.
Okay, so it just ignores it. If you had more code in there, then it would execute that. Otherwise, it would just ignore the redundant stuff.
Right. Well, so not exactly. What we need to do is we need to avoid all the errors, because the errors typically stop your script. If you have an error, it typically does stop your script. So we need to have a way around that, right? So what's the problem here? When I say I run it the second time, it says that the database is already there, right?
Yeah.
The database is already there. So what I can do, rather than just always saying, well, let's create it, maybe I say before I create it, maybe I need to delete it first. Okay. And generally the word for, the opposite of create a thing is drop in SQL terminology. So if I say drop database, if exists, if I run that first, I can tell it to drop the database, but only drop it if it is there. Because if I just said drop database, that will give me an error if it's not existing. So I can run this here. The second time I run that, you see it doesn't exist. So it says it can't drop it. You see that? So drop database normally throws an error if it's already, if it's not there. So I want to say I only run it if the database is there, we'll drop it. So I drop it and then create it, and that way I can rerun this script multiple times till I get it to the place I want it to be. Does that make sense?
Yes, that's good. That's helpful. So that's a best practice there. Put that at the top.
I wouldn't say it's a best practice, but it's what I need you to do for this initial setup. The problem with this is that you're deleting the entire database, right? So that's not a best practice in terms of something you wouldn't want to do with a real application. Does that make sense?
Oh yeah.
Because you'd be losing everything if you did that. But this helps me get a copy of the database that you have, and especially when you have changes to pull down other versions, right? Because that's what effectively what I need to be able to do is get to exactly the point you are at so I can grade your assignment. Does that make sense?
Yeah.
So the reason I'm structuring it this way and building it out this way is because I need to be able to replicate the database that you have on my computer. Okay, if you just go through all the GUI stuff, then it's a database that you have in your computer, but I have no way of getting. Does that make sense? So other things I might want to do as I'm going through this is probably comment some of these sections, because there's going to be a bunch of different pieces to this. So this first part is what we would say we are create the database schema. And if I hadn't mentioned this already, once we finish this here, I'll go ahead and put the whole file out on Discord, so you can have a copy of that. Even though you're not following along, then you'll have a finished version of this. Okay. So we've created the database schema. What might make sense to do next after we've created the database?
Create a table.
Create a table. Okay. So let's go start creating tables. So what table should I create first?
Order.
Okay. So order, or I could create product first, right? Either of those are valid, right? I'm just not going to create the order product first. Okay. So let's say we create the order table. Okay. Pull up my finished version here. So I'm going to say create table orders. Now I do want to actually prefix this with the name of the database. So it's going to be cowboyboots3.orders. And I need to specify the columns that table has. Increase the font size a bit on here. So if I'm looking at my diagram, I can see that my order has 3 columns. It's got an ID, it's got a payment date, and it's got a ship date. So that's what I need to add in here. Okay. So I'm going to add this in as ID int not null. Okay. So we know that needs to be an integer. We know it doesn't. We don't want it to be null, right? Because it's our primary key as well. I'm going to mark this as auto increment. Do you remember what auto increment does?
Every time you make something new, the number goes up by itself.
Yep. So it automatically gives us new numbers. Yep. And it goes up by itself. All right. Now I need my payment date. Now I've got a few options for the data type here, right? So in SQL there is a date type, there's a time type, or there's a date time part type. If you put in date, then you just have a date. If you put in a time, you just have a time, right? Now if I'm looking at payment date, I probably want both of those pieces. I probably want to know both the date that they paid as well as the time that they paid. Does that make sense?
Yeah.
So even though I've called it payment date, this is actually going to be a date time. And I want to say, well, this could be null, right? They could have not paid for the order yet, right? So at that point, there wouldn't be a payment date. So similarly with the ship date, that's going to be a date time as well, because I want to know not just the date it was shipped, but the time it was shipped. And then that could also be null, because initially we don't know when it's going to be shipped. Okay. So I've got my columns defined, right? Now,
Yep.
I need a primary key, because remember all your tables need a primary key. What's my primary key on this table?
The ID.
The ID. Okay. So I'm going to put primary key ID. Okay. So that's enough to get started with my order table, or my orders table. Okay. And I usually name these plural as far as the table names go. So the next table would be which table?
Product.
Product. Okay. So let's create the product table. That needs to start with create table. And then it's going to be cowboy boots 3 dot products. Okay. And if I go back and look at my ERD, I'll see that that's got 4 columns here. So I've got ID, name, category, and price. So same way the other one is, the ID is going to be int, not null, and auto increment. The name, I want that to be a varchar because it's going to be a string of sorts. So it's going to be maybe varchar, maybe say 100, give it up to 100 characters. And I want to say that that is required, so it's not null. Now, one thing you might notice on my name column, notice how that's a different color. Notice how the word name is a different color.
Why is it a different color?
What are your theories?
It's what's it called? Reserved word.
It is it's not a reserved keyword, but it is a keyword. So in some cases, the name is a keyword. In this context, right, I can use it and it will actually be okay. And that's why it's not reserved. A keyword that is reserved can't be used anywhere except for the intent that it's meant for. So SQL in general is a little bit lax about that, where in certain contexts it will let you use the keyword, and in other contexts it might not let you use the keyword. Okay? So maybe I want to clarify that because there are some cases where I want to clarify that it's maybe a column name or identifier name instead of just a word, instead of a keyword. So in order to clarify that it's an identifier, MySQL uses your grave marks. Now, if you're trying to go to another database system, pretty much all the database systems disagree on what defines the delimiters for an identifier. So in theory, SQL is a pretty standard language, and you can use it with any database. It's pretty close. So writing SQL for, say, SQL Server or MySQL or Postgres or Oracle, there's a lot of similarities. But there's always places that you get into where there's differences from one flavor of SQL to another flavor of SQL. So this is one case where there is a difference. So MySQL uses graves. Okay. If you're trying to do stuff with maybe like SQL Server uses square brackets like that instead to do the same thing. Cool.
Yep.
So just keep that in mind. If you're seeing if you're looking at other tutorials or other languages, if you're looking at different database systems, their variant or their flavor of SQL may vary from your own. So I'm going to put graves around that, and then it's actually usually good to get in a habit to just do that everywhere. So usually I'll go in here and honestly usually put graves around all of them, even if it's not needed. Does that make sense?
Yes.
Okay.
Maybe.
So one thing to keep in mind there, obviously, I'm using graves here for identifiers, but anytime I need to put in a string, I'm going to use single quotes. So you remember in JavaScript, if you're creating a string, I have 2 options for creating a string. I can create it with double quotes or I can create it with single quotes. Different flavors of SQL, when you're actually giving string literals, may allow double quotes, some allow just single quotes. So in general, regardless of what flavor of SQL you're running, usually double quotes work. Single quotes work. double quotes actually only work in some flavors of SQL. I think like SQLite lets you do double quotes, but like SQL Server doesn't let you do double quotes. So you do have to pay attention to things like that when you're dealing with different flavors. Anyway, so we've got an ID, a name. I need a category. Okay. What type am I going to use for my category?
Varchar again.
Okay. How long should it be?
15.
So I've got a
I don't know, 20, 25.
So I've got a pretty narrowly defined application right now, right? What are my categories that I support on the website? Because remember, we only defined 3.
Hats, belt buckles, and actually, no. Was that it? No, those are the products. I think it was the children, adults, and old people.
No, it's hats, buckles, and what was the other one?
Boots.
Boots. Okay. So of those strings, which is the longest one?
Belt buckle.
Buckles. Okay. And I'm shortening that from belt buckles to just buckles, right? What's the length of buckles?
Like 7, 8.
Maybe 7 characters. So I'm gonna limit that to 7 because at least for the system as is, I don't need more than that. Does that make sense?
Yeah.
So I'm going to save myself a little bit of space by making that limit a little bit more narrow. If I didn't know those categories ahead of time, yeah, I would just jump up to 20. If I didn't know what they're going to be, but since we've already defined them, I can narrow that range. Okay. So the category should definitely be required. So that's also going to be not null. And then I need the price. And remember we talked about that should be really a decimal because I don't want to have any rounding error on my price. If I use a float or a double, I will get rounding error there. So I need to specify how big that is, though. So remember we kind of talked about maybe the biggest price would be somewhere on $1,000. So that gives me 4 decimal places before and 6 and 2 after, which gives me a total of 6. So that's where I'm saying 6. If I had different price ranges, right? So if I were trying to sell cars, would this be enough space?
No.
Probably not, right? If I'm trying to build a banking website, that 6 might not be big enough. So you do have to kind of judge that based on what you're building and what those ranges are. Okay. So that won't always be 6. That's just what it makes sense for here. And then I'm also going to say that is required. So those cannot be null because I need to have a value always for all 4 of those things. Okay. I still need to add a primary key, and actually I should probably put the graves around there to mark that as an identifier. Okay, so we have a orders table and we've got a products table. Okay. Questions so far?
Nope.
Okay. Why did I do these ones first?
Because you said that you couldn't do the order product one first.
Mm-hmm.
Because those, in order to have foreign keys on the order product, you would have to make product and order first.
Right. So the tables with foreign keys I need to create after the other tables that they depend on. So the order of that creation is important. Otherwise, I'm going to get errors when I try to set up those foreign keys. It's going to say, I don't know about that table. That table doesn't exist. Okay. So I can run the database. I can run the script at this point really quick. Let's see what happens. So go ahead, execute. It says it's all happy. So it says, okay, it created the database, created the table, created the table. You'll notice on the left, do you see my database? Where's Cowboy Boots 3?
You have to refresh, right?
I do have to refresh. So there's a little refresh button up here. You may need to click to see it. So if I refresh there and then click in, I can see I've got that, and I've got my orders in my products table. Cool. If you expand that in further, you can see a few things. For instance, you can see the columns on the table, and we can see, if there's any indexes. You can see that both of these have a primary key, a primary index, but they don't have any other indexes. They don't have any foreign keys right now. So let's add the next table. Okay. So I'm going to create the order product table. So we got the order product bridge table, and I'm going to say create table. I want to prefix that with the name of the database. So it's going to be Cowboy Boots 3 order product. Okay. So let's go back to my ERD. And within there, I can see, okay, so order ID, product ID, quantity, and price, right? So I'm going to enter all four of those columns first. So we'll have the order ID. Okay. Now, what is the data type of the order ID column?
Int.
Int. And why does it have to be int?
Because it's a number.
It has to match the type of the actual order ID.
Yeah, it has to match the type up here. So like if this was big int, then down here the order ID would also have to be big int. It needs to match what it's referring to, what it's referencing. So whatever type that is, I also need to have that data type down here. Cool. So this will be int because the other thing is int. I'm going to say this cannot be null. Okay. And then let's also add in the product ID. That's int by the same token because my ID here in the products table is an integer, so this one needs to be an integer. Now, I would ask, you'll notice how both of these tables, we've marked the primary key as auto increment, right?
Yeah.
So remember that means that I'm auto-generating an ID, right? Should I mark these as auto increment?
No.
Why not, Troy?
Because they're already being auto incremented
Right.
in tables that they come from.
They refer to the column here, right? They refer to the values in the other table, right? So I don't need to auto-generate a value here, but it's because it's already been generated in the other place. And that's sometimes the place that people get confused. That's one of the places I see a lot of students get confused is they think that, oh, I need to also, because this is the primary key is always auto increment. Well, it's not the case. It's only the case that it's auto increment if it's, it really belongs to that table, right? So I could add, as far as the primary key, I could add another column here, right? This is kind of an artificial number, right, that belongs to the order product. In that case, this would make sense to make that auto increment. With me?
Yeah.
But I don't want to make either of these two auto increment. And there's one rule that you'll get into and you'll see sometimes is if you try to add two columns like this, if I tried to add both of these as auto increment, let's see at the error that it's going to spit out to us. So let's say I have that like that. I need to pull off the comma at the end. Okay. So it says incorrect table definition. There can only be one auto column, and it must be defined as a key. So that's the error you're going to see if you do that. It's going to say you can't do that. If I remove this here, it won't complain about it. It will still complain that it isn't the primary key yet. But either way, those are kind of the errors you'll see.
Mr. Smith, bridge tables by definition, they're just going to be that way. It's going to be a composite foreign key, but we'll identify it as a primary key there as well.
Not all the time. Not all the time. Sometimes it does make sense in bridge tables to add another column. Okay, and so sometimes this is the way to do it. Still, you add an ID column. But with this application here, let's think about what that would mean if these are duplicated. Let's say I've got two rows here that have the same order ID and product. What does that mean?
That would mean the quantity went up, yeah?
Okay. Well, that means, yes, that there's more than one item in that order, right?
Well, if it's the same product ID, it would also be the same item as well in the same order.
Okay. So let's say I'm ordering two products, right? And I want to order, let's say I'm ordering two pairs of boots. They're the same product ID, but I want to order one that's red and one that's blue. Does that make sense?
Maybe.
So,
yes.
So if I have, let's say, as in this junction, let's say I have color, right? That's no longer, this thing by itself is no longer unique. Do you see that?
Yeah,
So,
I could see it.
Because it's not really unique, that's where I would want to introduce an arbitrary sort of thing. So it depends on what sort of multiplicity that you want to see. If you want to see duplicates with those reference bridge things, with the foreign keys, then you really do want to add another column. Okay, but if you don't want to see duplicates, if you want to say, well, we'll merge all the, every time you add the product to your cart the second time, we won't add another record to this table, we'll update the existing record. In that case, which is what we're doing here, then it makes more sense to use that as the primary key. Cool? So the question is it unique or is it not unique? Because remember, what are the three requirements for primary keys?
Fixed, unique, and not null.
Fixed, unique, and not null. So both of these satisfy the not null. They both satisfy the fixed, right? In the sense that I'm not going to go edit them or change them after they've been graded. But they may or may not satisfy the unique constraint, depending on the kind of system I'm building. Depending on some of the other things that are going on there. But
so we would need to set that up, right? Because these are going to be identified as primary keys. Mm-hmm. These order ID and product ID. You just type the word unique in there.
Yeah. So for this example, they're going to be unique. So I will use them as the primary key. So I've got the order, and then I need to add the quantity. Quantity. How big does that number need to be? Well, maybe like we talked about previously, it doesn't necessarily need to be an int. It could just be a small int. And depending on what your stocks are, it might even be a tiny int, right? Because a tiny int still lets you get up to 127, right? So that could really, for this system, this could be a small int or it could be a tiny int. It doesn't need to be a full int. Okay. Now, I do always want to have a value for that quantity, right? I always want to have a value for that quantity. And then I also need to have the price. So the price I probably want to be the same type as what I have up here. That'd be the price of an item. Now, should that price be mandatory? Should it be required?
Well, what you had said before is we may alter the price because it may be discounted, so it should be defaulting to whatever is the price as we defined it in the product table.
Okay.
Or possibly manipulate it afterward.
Right. So when I add the thing to my order, right, at that point I should definitely save the current price, right? Now, there's a question here in the sense that when does my order get created? When do I create my order?
When something is like added to a cart or something.
Okay, so that's one idea. I could create the order when you add things to your shopping cart. What's the other time I could create the order?
Checking out.
I could create the order when you actually check out, when you actually pay, right? So I could create the order object at payment time, or I can create the order at when you add it to the cart. Does that make sense?
Yeah.
Does it matter? Does that question matter?
I mean, if you had it to every time they added it to the cart, you'd have to update it every time, so I guess for that reason. Versus just making it once when they pay.
Okay. So one of the things to consider, right? Anytime I put something in the database, the whole point of having a database is that it's persisted, right? So it lives through crashes and long term, right? So let's say a user starts their order, right? And then they leave it and they come back to it a week later, right? If I have it in the database, as soon as they add it to the cart, right, will that order still be there? Will it still be there a week later?
Mm-hmm. Yes.
Okay, it will be.
Yeah.
What if I were to say store your shopping cart? What if I instead stored your shopping cart in your browser's memory? What if I stored it on the browser side? And would it necessarily be there when you come back in a week?
No. I mean, if you delete your browser history, wouldn't that mess it up?
That might be a thing. Yeah. What if I start the order? What if I start putting stuff into my cart on my phone, and then I switch to another computer, right? If I just have it in the kind of the browser cookies or the browser data, there's more than one way to do that. It won't be there, right? It won't be there when you switch computers. Does that make sense?
Yeah.
Versus if I put it in the database immediately when you start putting things into your shopping cart, it can still live through you switching computers potentially. So there are some definite differences in behavior depending on what approach you take. If you say, let's start adding it to the database at checkout time and don't add it till then, well, then the user potentially could lose what's in their shopping cart. Versus if you immediately start adding things, things that they add to the cart, you immediately start putting that into the database, then you have more chance at persistence, and then you have things like maybe you can send the customer a reminder that, hey, they put something in their cart, but they forgot to check out, right? You can send them an email about that. So there's a lot of reasons that you may want to put it in the database or you may not want to put it in the database. But I would generally lean towards put it into the database the second that they add it to their cart. Does that make sense?
Yeah.
So those are options. Now let's say I do that. Let's say I'm taking the approach that this record, the order and the order product, gets created as soon as I say add to cart, right? What would be the benefit of saving the price right then? What would be the benefit of saving the price when they add it to the cart?
It'll be updated with the latest thing that they put in.
I'm specifically talking about the price, right? What happens if at that point I put the price in the database?
Well, it's one less thing to retrieve or to worry about later because it would just be there.
Okay. So it might save me some work later when they go to actually make the purchase, or if I want to look at that price, I don't have to go back to the product table to look at that price, right? But what?
Yeah, it wouldn't be null either. You could have it where it would be null.
Right. So if I set it immediately when you put it in the cart, then I can mark this as required. But the problem with putting it immediately when I add it to the cart is what happens if the price changes between when you add it to the cart and when you make the purchase. What happens if I add it to my cart and then a week later the sale ends and it's still in my cart for the sale price?
It's a lie.
Right? That would be a problem, right? That would be a problem if the wrong price is in there. Does that make sense?
Yeah.
So actually, I'm going to let this be null because I don't want to put the price in until they actually pay me. Does that make sense? I'm going to put the price in when they make the purchase. Because at that point, I want to know what they paid for it. But before that, I want to make sure that it's reflecting the actual current price of the item. You with me there?
Yeah.
Okay. So sometimes things like this seem like a really trivial piece. Should it be required or not required? But often that decision between null or not null is a really important one. And it will influence your code in a lot of ways. So keep that in mind. There's not always just one solution. But I think that in this solution, allowing it to be null means that I'm less likely to have those kind of problems. Because otherwise, I would have to somehow figure out how to update all the prices in your shopping cart when you go order and say, have they changed? Versus if I just say, let's not save the price until you order, I don't have some of those problems. Okay, so I've got my columns. I need to define my primary key. So you'll remember that we said the primary key is going to be both of these things together, right? Not one by itself. So you saw how I wrote the primary key like there with just the ID. In order to specify this as the primary key, I'm just going to say order ID, comma, product ID. Cool. Now, that's how I can create a composite key. It's worth noting that as I'm doing that, does the order of these two columns matter? It does. It does have some effect, and it will have some effect in terms of your query performance, because this does create something called, anytime you're adding a primary key, you're also creating kind of implicitly an index or an ordering for the data, the rows on the disk. So with the primary key, that means that because I've got the order ID first, that means it's easier, it's quicker to look up these rows by the order ID than it is by the product ID. It's quicker to look it up by the order ID than the product ID. Is that what I want?
Nope. Yeah.
When I look up the order product, when I look up the rows in this table, which of those two numbers am I more likely to know? Am I more likely to know the order ID, or am I more likely to know the product ID?
Order.
So if I'm looking at my shopping cart, for instance, sorry, let's say I'm looking at a previous order, right? And I want to see all the stuff that went into that order, right? Well, if I'm looking at that, I know the order ID. Does that make sense? That's kind of the most common operation for users to do, is they want to look at one of their previous orders, right? Now, sometimes for reporting purposes, you may actually want to look the other way around. I may want to, as maybe the store owner, I might want to see how often a product's been purchased. Does that make sense? At which point I know the product ID, but I don't know the order ID. You with me? Now, how often might I run a report like that as a store owner? How often am I going to say, well, I'd like to know what products are selling well?
Probably pretty often.
Give me a rate.
Once a week, twice a week.
Once or twice a week? Okay. How often are customers looking at their orders and seeing and checking up the status of your order?
Multiple times a day.
Multiple times a day, right? Which is more frequent?
Order.
Okay. So it would need to be in this order for performance reasons. Does that make sense? Because that's the way that it's going to happen most frequently. It's going to be users looking up their orders by their order ID. It's going to be less frequent that customers are looking up their orders by their product ID.
So it would just work faster. It doesn't matter. If time wasn't important, you could do it either way.
If time wasn't important, it doesn't matter. But what it does is it changes how fast your website is for actually anything you do with this table. So this means that anything I do where I know the order ID will always be faster than anything I do where I don't know the order ID. So yes, if time were not a constraint, then it wouldn't matter, but time is nearly always a constraint, so it does matter. So we've got that structure, and that's all three of our tables, right? So if I hit execute, I should see this here, right? Now let me refresh. Let's look at the database. Okay, so I've got my 3 tables, right? And you were asking about putting data in, right?
Yeah, the most efficient way of doing that.
Let's try the, is that what I want? The table inspector? No, that's not what I want. So, save me script. I would want to, table data adds for, try to remember. I think I can, yeah, I can just type in here directly. So let's say I pull in here, I'm looking at the records. Let's say I go 1, 2, 3, 4, hit enter, and let's see if this will edit current row. Oh, no, I want to say insert row. And where am I? Nope, I want to.
Hey, did you set those up? Those are supposed to be foreign keys, right?
I didn't yet, right? So let me save that real quick. Save changes.
Sorry about that. My internet.
Oh,
went
there
out.
it goes. I hit apply. Oh, it's the apply button down here. Okay, it's complaining. There, that's what I need to do. Okay, so I'm going to go to order product and back into that table no, not table inspector. Select top 1,000 rows. So I'm going to select that. 1, 2, 3, 4. Apply. There's the insert statement for it. So effectively, I've changed the table, right? So I've inserted a row into it. So you can do it that way. Does that, so I can do this and start putting those values in 5, 6, 7, 8. Apply. Okay. So
And that would be the preferred way of doing it, is doing it in order product, because you got everything right there.
No, this would not be the preferred way to do it. Okay. The point is you can do it this way, right? But I would say you see it's kind of end up generating an insert statement for you anyway. I think it's better for you to kind of insert the data using insert statements using a script. You can do it that way though. You'll notice, yes, you're talking about the foreign key, right? I haven't put my foreign keys in yet. So did it give me an error when I put these records in? About using like 1, 2, 5, 6?
No, I don't think it did. No.
It didn't. Right? So right now there's no orders and there's no products, right? So in here I'm referring to order ID 1 and order ID 5, but those don't exist. Also, 2 and 6, product IDs 2 and 6 don't exist, right? So I can't go find like what's the name or what's the price of those products, right? So without the foreign key, you can build these without the foreign keys, but if you don't have the foreign key, you see the constraint is not, there's not a constraint on what I put into those fields. Questions about that? So without the foreign key, it's unconstrained.
Yeah, if you put data in without setting up those foreign keys, you could really screw things up on an established database, huh?
Potentially. Although there are cases where I might want to have data that's in a weird state like that for auditing purposes sometimes. But in general, that is something I want to avoid. So let's add the foreign keys. So I'm going to add foreign key in here. And let's say the foreign key, the kind of syntax here is I need to write the keyword foreign key, and I need to say which column in this database here is the foreign key, right? So here I've got the order ID column, right? That's the name of it here in the order product table, right? Is that the name of it in the order table?
No, it's just ID, isn't it?
It's just ID, right? So what I put here first needs to be the name of the column in this table, okay? After that, then I write references. That's another keyword. I write the name of the table that it references, right? So this column, this order ID column, references the orders table. So it references the orders table. And the column in the orders table it references is the ID column. So that's what my foreign key looks like. I have to tell it what column is it in this table and what column is it in the other table to create that connection. So I need to do the same thing for the product ID. So it's named product ID here. And when I refer to the products table, it's the ID over in the products table. Does that make sense? I know somebody yesterday, we were asking about like the category and the category name and how it figures out what's linked. That's how it figures out what's linked. You tell it. It doesn't make any assumptions based on the name. So let's say I've named this this foobar, right? I could still put foobar here and say foobar refers to the order ID, right? So the only reason, but it does help to actually name it at least for readability purposes to kind of have an idea and at least an expectation. Cool. So that's that. So let's say I'm going to execute this now. Okay. So we got the foreign keys in there now. I'm going to try to look at the database here again. So remember, every time I run my script, I'm deleting the database, right? So my records here are gone. Now, if I try to insert 1, 2, 3, 4 now, remember, there's still no order ID 1. There's no product ID 2. So if I hit apply and we run that insert statement, see what it says? There were errors while applying the SQL script to the database. So specifically here, I can see the error, right? So the error says, cannot add or update child row, foreign key constraint fails. See that? So now that I've got my foreign keys in there, it's saying you can't do this because I don't have an order ID with that number. I don't have an order ID name with 1. And you can also see that in here, so it says a constraint fails, but it also tells us which constraint fails, right? So this is the name of our constraint, is order product that. And the second part here is randomly generated because we haven't given that foreign key a name. So it's just taking the name of the name of the table plus some random characters. Does that make sense?
Yeah.
So the foreign key prevents that from happening. Okay. So that's what your foreign keys really do for you. Okay. Are there any other foreign keys that I need to add to the schema as I have it?
Doesn't look like it.
Doesn't look like it. So, and that's kind of where, as you have more tables, when you're actually building this, you're going to have foreign keys on a lot more tables. But I figured just doing it at least one table with got foreign keys, you can kind of expand from there. Okay, so we got foreign keys, we've got the 3 tables created, and you can see that I can run this script regardless of what state my database is in, it will end up working. You with me?
Yeah.
Yep.
I am dropping it and recreating it every time, but I can at least use this to be able to then give that database to somebody else and transfer it from computer to computer. Just the script contains all that information.
When we're doing labs and other assignments to turn in GitHub, we just put it in a folder and sync it with the SQL command. Is that how it works?
Well, you want to save the file. So I don't know what SQL command you're thinking of, but you're going to save this file to your project folder. And the place I would say where to put it, say open, let me say save script as, in your repository. So let me go into... So where I want you to save it is in a folder named data. So whatever project name it is, so this would be the Cowboy Boots project, I make a data folder underneath there and save it as schema.sql. That way it's easy to find.
Okay, so that has everything in it, including creating it plus the data that's in it. That's really the only deliverable is that .sql file.
Right, yeah. So for your database design lab, this is the file that I need your ERD diagram for it, and then this is the file that I need to have your schema. Okay. So I've got all of the create table statements in here to create all the tables. You did mention data. That's not in here yet. I still need to add that. Okay. Before I do that, I want to mention real quickly, I mentioned in lecture that you should generally have indexes on your tables as well. And those indexes are going to speed up your query performance. You'll especially want to make sure you add an index anytime you have a foreign key, again, for performance reasons. So that index makes it easy to look things up by columns that are not the primary key. So if I'm thinking about, for instance, orders, right? I can quickly look it up by ID because that is the primary key, but maybe I want to be able to look up my orders by some other things, right? Maybe I want to quickly be able to look up your orders by like the payment range. Like give me the orders that you've paid for in the last 90 days. Does that make sense? So if I leave this as is, anytime I go into the orders table, I have to look at every record. Any query I do over here, I have to look at every record to find ones that fit that payment range. Cool?
How do you index it?
Huh?
How would you index it? You said to do an index, but I don't know how to do that.
Yep. So we're going to do that right here. So we want to say create index, similar to how we kind of said create table. I'm going to say create index. I need to give it a name. So the convention I use is kind of, you can technically name the index as anything you want. The name I use is basically take the name of the table plus, or take the name of the entity plus the column name. So we might want to index the payment date. So it would look like this. I'd say create index order payment date. That's the name of the index. And then it's on the order's payment date. What that means is anytime I have a query now that goes off the payment date, it can go look that up quickly rather than having to go through all the rows. But this does this will speed up your query performance. It also oftentimes will speed up your updates and other operations that you do with the database. It does come with a little bit of overhead because every time you change the database, now it always has to update that index, right? So there's a little bit of a trade-off, but because most databases end up being driven more by users reading the data rather than changing the data, it's usually worth adding indexes for anything that you might want to look up. So I can add one for the payment date. I also would want to add an index on the shipment date. So that way I can easily look up any orders that, they were paid during this window or that they were shipped during this window. Does that make sense? Do I need to add that for every column? No, I don't need to add that for every column. I just need to add it for the ones where we might do queries. So what about the products table? What columns in here would it make sense to do a index for? Okay. Well, ID automatically gets one because it's the primary key. What about name? Might it make sense to index the name?
Yeah.
Why?
So what people will search for when they're looking for that product is by the name.
Okay. They'll probably look for the product by name. Okay, that's reasonable. But, so I could create an index there. And I should. I do need to create a little kind of a special index. And for name specifically, I want to create what was called a full text index. And the reason for that is if I'm looking for something by the name, I probably don't know the name exactly. Does that make sense? I probably don't know the whole name or know every character that goes into the name, right? So I'm going to be doing a partial match on it. So I want to make that a full text index because that's designed for strings where you want to do partial matches. Sheridan, do you have a question?
No, sorry, my control is my push to talk.
Just checking. So product. So I would create an index there for the name. What about the category? Are people going to look up products by category?
Probably.
Yes.
Most definitely, right? Because I'm going to have somewhere in the website that's going to say, show me just the belt buckles, right? Or show me just the hats, right? So that should be definitely something we index. So the same kind of thing. I need to add an index for that. Okay. What about the price? Do customers ever look up products by their price?
Yeah, cheap customers.
Okay. So why would a cheap customer care about looking up, thing by price? What might they do as their query?
They're trying to get their boots for like not $1,000 but $9.99.
Uh-huh. They're looking for the cheap boots, right?
Yeah, the cheap.
So if I say, well, let's just show them all the boots, right? Well, maybe they want some sort of price range, right? They might say, I only want the boots that are less than $20, right? Does that make sense? Or less than 100 or whatever it may be, right? So they might want to do some sort of price range filter.
So we wouldn't index it. We would put a price range.
No, I would index it.
Oh, okay.
So indexing it makes it faster for anything where you say, I want to filter the data by that column. So if I want to say I want all the products in your database that are less than $5, this makes that faster. Because what it can do is then it can only look, only has to, it kind of has them already ordered from lowest price to biggest price is what this index does. So it can just say, okay, I only need to look at these products. It doesn't need to look at the entire database of products that you might have, which that might be thousands of products, right? So if you're just saying, I have this index, it may be able to only get to the 100 or so products that are under $5 instead of looking at all 1,000 products. Does that make sense? So that's an important consideration when you're dealing with creating your database and thinking about your schema is think about indexes, right? For the order product table, the indexes that I would add there, because there's primary keys, I want to easily be able to look up the data going both ways. I did mention here that the order of the order ID, that one's first, so therefore that's quicker. However, if I just add an index on both of those columns, it actually doesn't so much matter, because if I want to look it up by product ID, I can use this index. If I want to look it up by order ID, then I use that index. So as a general rule of thumb, anytime you add a foreign key, you should also index that column. Does that make sense? Because by you having in a foreign key, that means you're going to be looking up by that thing at some point. Darnell, were you trying to say something?
Did you hear me, Mr. Smith? I said yeah.
Yeah. Okay. Okay. So that's one thing that I would expect to see in there as well is give some thought to what might you need to look up the data for by the indexes as well. So now that we've got all the structure, we've talked about the indexes. Let me get back to actually putting some data in. So let's say we're going to populate the tables. Okay, it's usually the term that we call for inserting the records. Okay, so we talked about the general syntax for inserting records, and you probably saw it with the Code Academy lab as well. So I'm going to say insert into the name of the table that I want to insert items into. So I'm going to say, well, let's insert products first. So I'm going to say insert into products. I need to specify which columns I want to put values in. So specifically here, I'm going to put in values for the name, the category, and the price. I'm going to put in the keyword values, followed by the actual data I want to insert. Okay, so I can insert more than one record this way. Each of the records kind of starts with parentheses, ends with a parenthesis, and then there's a comma between each one until I finally get to the last one, and that would be a semicolon. So here I'm inserting 3 rows: baby boots, several buckle, wide brim hat, with their categories, boots, buckles, hats, and their prices, right? So I'm inserting those three columns. Okay, so that's your general syntax for products. Okay, now let's say I do that. Let's say I want to go and execute this. I think I may need to run the whole script. What did it tell me? Oh, no database selected. I forgot to prefix it with the name of the database. I need to do that here and here and here, and I need to put that on all my indexes as well, because they need to know what table that goes with. Okay, there we go. So I can run this statement again, but notice, does it ever give me an error as I keep hitting insert again and again and again?
No.
Okay. Let's look at what's in that table. So if I just do, actually I just do here, select star from Cowboy Boots 3 products, that will show me all of the errors that are there, all the records that are there. Okay. So I can see there's a bunch of duplicate products. You see that? I want to avoid that. So how can I avoid getting those records inserted multiple times? What could I do?
Oh my gosh, I know it. I just can't think of it.
Well, so you want to change how you're inserting them and not how you're searching them from the select.
Okay.
Because I was going to say you can use a select distinct to change.
Well, I couldn't because the IDs are still different.
Okay.
If I said just select, like for instance, if I said just select the name, I could say select distinct name, right? And then I'm getting not duplicates in the results, but those records, those duplicate records are still there in the data. Does that make sense?
Yes, sir.
I'm just looking at them. That just means my view doesn't show them, right? But they're actually still there. The fact that I select them differently doesn't change the fact that they're there.
Change that. Yeah.
And the problem is really that they're there. They shouldn't be allowed to be there. I want to make sure that that doesn't get inserted more than once. So what's a word to say that? What's a word I could use to say that these need to be needs to be no repetition? What do I want not to be repeated?
What do you mean?
So how do I know?
The ID, right?
Well, these have ID 3 and ID 6. That's fine. You're kind of on the right track, but ID doesn't...
I meant the name, sorry.
The name, right?
Right, the name.
So I don't want any duplicated names, because that's likely because that's basically duplicated products. So I want to make sure all the names are different. Okay. So in my products, I'm going to add in a constraint that the name needs to be unique. So I'm going to say unique name. So now that I've made the name unique, the next time I try to run this insert, you see it gives me an error. It says duplicate entry baby boots for the key product.name. So unique constraint helps there. Questions?
I ran into an error with it.
Yep.
Now, I thought that first command at the top where you drop the table, that would delete everything. So why would there be a duplication error anyway?
Well, remember it only runs the stuff that I have selected, right? So right now I'm just selecting part of my script. That's oftentimes something you need to do as you're testing it. You may want to run just part of the script.
Okay, I didn't highlight anything and it still did it.
I don't know. If you may not have the drop correct. I'm not sure. But that's why this is happening, is because I'm not running the drop every time, because I just have that selected. Okay. So the other thing I can do, because oftentimes, again, I want to run this maybe in isolation. The other trick I can pull is, let's say, well, maybe if I delete all the records, right, before I insert records, then I know there won't be extra copies. Does that make sense? If I delete all the records first, then there won't be extra copies in here. So there's actually two ways to delete all the records from a table. You can typically say truncate table, and then I would put the name of the table. So in some databases this works, and the general thumb is that's usually quicker, because usually truncate table, all it does is it just sets the count of rows in that table to 0. It doesn't actually go through and delete the records. It just sets the count to 0. So that's usually quicker. However, if I run it, one of the things you'll see kind of that happens with MySQL, at least the way they've implemented truncate, notice what it says here. Cannot truncate a table referenced in a foreign key constant constraint. So the way that MySQL is set up, I can't actually run truncate table on these tables because product is used as a foreign key. Even though there's nothing in order products, it might be, so it doesn't allow it to happen. Got it?
Yep.
So that's usually the way I would recommend doing this, but that doesn't actually work with MySQL. So the way I need to do it instead with MySQL is I'm going to do a delete from. I'm going to say, let's delete the records from the products table. So if I try to delete it, I get a different error. Okay. So this is the syntax to say, I want to delete everything from that table. Okay. Now, you don't want to do that by accident, right? Deleting everything from a table is probably not a good thing to do accidentally. Make sense?
Yes.
So,
Yes.
So MySQL's got a little check in here. You're saying, oh, you're deleting everything. We don't want to let you do this. So they're saying you're using safe update mode, but you don't have a where clause. So typically with our delete statements, we'll include some sort of where. So I might say where the ID is 3, and then I'd only be deleting one row, right? That only deletes the row with the ID 3, and it's okay with that. Right. So generally speaking, your delete statements are going to have where clauses in them. And that's because we don't usually want to delete all the data. Okay. But here, I want to delete all the data. Right. So there's a little bit of a workaround that I'm going to add in for this script in particular. I'm not normally going to do this, but I'm going to do this because I want to be able to set up the database and have it in a predictable state. So there's a special setting that you can use with this command, set settings in your SQL session environment. And so we're going to set the setting called Sql Safe Updates. We're going to set it to 0, which means it's turned off. So by setting that to 0, we can now delete the entire table. So if I try to run this now, it's going to go ahead and let me do it. So you'll see every time I run this, I delete all of the records and then create new records. You see that?
Yeah.
Okay. Now, it's interesting to note, we'll look at the IDs. What are the IDs?
25, 26, and 27.
Same where they left off.
What would you expect them to be?
To reset.
You'd probably expect them to be 1, 2, 3. Right? So anytime you delete a record, we've got an auto increment column here, which means it remembers what the next number would be. When I delete records, it doesn't reset that. Does that make sense? When I delete records, it doesn't reset that back to 0 or back to 1. So every time I run this, my IDs keep going up. Cool.
Yep.
Which turns out for this I can end up working out because I'm deleting the whole thing up at the top. So it'll go back to 1, 2, 3 once I delete the entire table. But that's not happening there. And part of the reason that's not happening is I'm not telling it when I insert it I'm not telling it the ID. See that? I'm not telling it the ID. So sometimes it's worth specifying the ID in there as well. So let's add some orders as well in here. I'm going to add in, let's delete all the orders. And then I'm going to add in the orders. Okay. So here I'm going to add 3 orders. I'm going to add them in kind of an interesting way so I have some data to test. So here I'm specifying the ID, the payment date, and the ship date. So here I'm actually saying I do want to specify the ID, the order ID. So you can, when you're doing an insert, you can put that in optionally. MySQL lets you do that, even though it's an auto increment column. You can say, this is the ID I want it to be. Okay, so this is going to get created as order 1, 2, 3. Okay. You'll see I have the first order doesn't have a payment date, doesn't have a ship date. The next order has a payment date and no ship date, and the third one has both. Now, when you put dates and times in SQL, in MySQL, it's actually very picky on the format that you put them in. So do you see what format that I put the dates in? Can you guess what format that is?
Year, month, date.
Okay. It has to be in that order. It has to be in the order year, month, date. It won't take it in any other order. So year, month, date, and then you've got, similarly here, can you guess what those 3 parts are?
Hour, minute, second.
Hour, minute, second, right? Now, 13. That's kind of weird.
That's 1. Military.
It's military time. So you have to put this in military time when you're entering times. So that's what MySQL expects your dates and times as, is year, month, date, hour, minute, second, and then the hour has to be in military time. So this would be like 1 p.m., 3 p.m., 5 p.m. So keep that in mind as you're putting data into the database, especially if you need dates and times. Okay. I can put some selects in here. The last that I might want to check as far as, that my script worked. So I'm going to say, check the data is correct. I want to do a search on the products. I want to do one on the orders. And you'll see if I do more than one select in my script, there'll be different tabs here. So for instance, I have the products and I have the orders. See those tabs? So those are the different results that I'm getting back. Cool. Now I might also want to insert some orders and products, right? So let's clear that out. Clear out all the orders and products. Then I'm going to add in a few. So let's say I add in, I'm going to add some products to my first order. There I'm going to specify the order ID, the product ID, and the quantity. Right? So I'm going to say, let's add 3 product ones to my first order. Okay, with me?
Yeah.
Did I have to notice why that I didn't have to specify like the name of the product or anything like that. I just need the values that go into that table. Okay. So that's that. Now, let's say I want to do something like this. Let's say I want to insert just the order ID and the product ID, right? Maybe I want to be able to do that. Okay. Now, if I try to insert, order 2, I want to add product 1, order 2, I want to add product 2. Oh, I haven't put in the database name. That's what's up. Try that again. You'll notice it says field quantity doesn't have a default value. Right? I haven't told it what the quantity is. But you see how that says doesn't have a default value? Does that give you a hint as to maybe what we can do?
Give it a default value.
Give it a default value. So sometimes it makes sense to go some of these columns and say, well, what's the default value of that column? Well, if I'm looking at order product, what would be a sensible default for the quantity?
1.
Probably 1. So by default, that represents 1 item. So if I run that now, I can insert these products. I need to do a select so I can see the results. Order product. So you can see both of these been inserted now with a quantity of 1, and specified the quantity so it's defaulting to 1. Does that make sense on the defaults?
Can you scroll up to where the default's at again?
Yep. So it's set as part of the column.
Okay.
If you don't specify a default, then the default it will try to go to is null. So for instance, you notice I don't have a default on the price. So it will default the price here to null. But it couldn't do that here. It couldn't default the quantity to null because it doesn't allow null. Cool. Let me do one last insert so we can add some items to the third order. So in here I'm going to specify all of the columns. So I'm going to say let's insert the order ID, the product ID, the quantity, and the price. I can do that, and I just specify all of those values. So you can see ones that are allow nulls or have default values. Both of those you can sometimes omit. Does that make sense? You can omit those if you know what it should start out as. So that can make your code a little bit cleaner if you have those initial, values. Any questions?
Nope.
Okay. So I have a database that's been populated, right? I've got all my tables created. I've got all my data in there. And we can kind of look at the overarching structure and series of things that we have to do, because you'll notice that the order of all these things matters. So the first thing I did is I dropped and created the database. Next, I created each of the individual tables. Along with the tables, I'm creating indexes that go with the table. And remember, those tables, I need to start with the ones that don't require foreign keys and then kind of build on from there. Any ones that require foreign keys are going to be later on in the creation. So this one's the third one because it depends on the previous two. And then finally, I can start inserting some data into the database. This is optional kind of at the end to select the data once you've inserted it, but it's really, really helpful to put that at the end just so you can check that everything worked. So that's the structure I want you to follow as you're creating your databases.
Okay, so the two databases that we're making are separate from the group one?
Yes,
All
separate
right.
from the group one. So you're doing this as an example, but there's the two that you're turning in as your own are not the same one.
Oh, there he is.
Hey.
So if we read the database through the editor, do you want us to just make it again, but through SQL commands instead?
Yes. So one of the things you can do if you've already created it through the editor, you can right click the table and say send the create statement to the editor.
Yeah, I just didn't know if you wanted us to do that because it adds like some extra things that we didn't really talk about.
Yes, you'll want to strip off those extra things.
Okay.
You can do it, but you need to strip off the extra things. I usually find in the end creating the tables from the script directly is usually faster than using the UI anyway.
Yeah.
But